Hi, let's look at multiple ways to represent user ID in a recommender system. Um, the contents of this um, code are in the repository user preference modeling on GitHub. Um, GitHub user preference modeling. So I'm sort of going to go through the code here. Let's start with the README. So yeah, like I mentioned, the representing the user um, preference in a recommender system has been a very effective way in building personalized recommendation systems, and personalization itself has been a key lever in like in multiple industries like ads, in content recommendation, in notifications, etc., etc. Today we are going to talk about a very specific aspect of it. There are many things that go on that you have to do right in a recommender system. A lot of it is about the infrastructure, the features, the freshness, and all of that. Today we're going to talk about um, yeah, how to model, what to do in your model so that you can learn the specific interests of the user and represent them well. Okay, so first in this repository, like I mentioned in the repository user preference modeling, let me give you an overview of it. The code is in source, and there are tests. There's a README, get ignore, etc. And there are a bunch of images which are used for the README. Okay, so inside the source, the first file you should look at is multitask estimator. Um, I'm kind of switching between the GitHub normal code and the VS Code instance of GitHub. This has a better README preview, in a markdown preview, in my opinion. That's fine. Okay, so the multitask estimator is this file, and you can look at the init later, but the main function you should start with is the forward function. But before I talk about the forward function, what is the multitask estimator? It is there's a part in a ranking system where you have a fixed number of items, let's just say 500 items, and you have features for them. You also have the corresponding user features and stuff. But for each of those 500 items separately, you're trying to come up with an estimate of various probabilities of various labels. Need not be probability. You can also have um, like a mean squared error based estimate. So like quantity. Usually you will find probability, so logistic loss, but again, not pertinent to our presentation today. What we're Let's pretend for a second that um, we are only working on task probabilities. So we have some input features for a single item and user pair. We have some user features and item features, maybe some cross features, and we are trying to come up with um, various probabilities of various tasks. Some examples could be like if you're building a podcast recommendation system, maybe your UI allows the user to, of course, listen to it, maybe follow the, like subscribe to the creator, maybe to like it, maybe to share it, maybe to comment. All of these could be modeled as various tasks where you create a logging system when these actions actually are performed by the user, so that you can later join it with your features and create a training data that, hey, for this instance, for this user, for this item, these were the features and these were the tasks that they actually selected. And if they didn't do any of them, like they didn't even listen to it, etc., so all of those would be zeros, and whatever they do will be ones. So right now what we're doing, this forward function takes in features, the user features, item features, and cross features. There's also position, but this is in the forward, it'll be null, it'll be non-important. In the training step it will be used, but ignore that. So using these features, we have to come up with the estimates. The neural network has to come up with estimates of those tasks. Okay, so I've drawn a schematic of what written in the code is. Let's start here. So using the item ID, we go through an embedding lookup and get the item embedding. We transform the item features through neural network module, and then get a fixed dimensional smallish output. Typically this will be much larger, and this will be smaller dimension, but this is a processing step. Similarly, cross features are processed and transformed, and user features into user features transformed. And this is slightly key because our repository and our talk is about how to represent the user. At this point, I'm pretending that all you're doing is specifically for that user, you're getting a user embedding. And later we will expand on this. We will generalize this. We'll make it more performant, and also maybe less memorization. Okay, so the general API function is there's this function called get user embedding, which takes a few inputs. It actually takes user features also later on, but the output of it, which matters, is a fixed dimension embedding. And then we concatenate all of these. So take all of these, and there is a neural network which tries to output the logits or the log probabilities of all the tasks, all the T tasks. So let's look at the code now. Yeah, so process features is what I mentioned. Process features for the item ID, the item features, the cross features, the user features, and the user ID user features. It processes them. It basically makes like transform fixed dimensional embeddings from all of them, concatenates them, and then so this calls process features, forward calls process features. This sends back the combined features, which is a concatenation of those transformations, outputs of those transformations. And then you have a task arc. I'll show you what this task arc in a second, but suffice to say it's a neural network which takes the combined features and outputs the log probabilities of the T tasks. So the task arc, and that is defined in it. Task arc is, right now it's pretty simple. It's just a linear layer. Obviously you can make it better, sequential, multiple layers, drop out, activation function, all of that. Okay, the out features is important. So it's one, so output is the logit per task. Okay, once more, the forward function gets the input for user item pair. It processes them and passes them through a task arc to get the per task probabilities for this user item pair. All of the transformations are in process features. We look at get user embedding, which in this case is not defined, it's just pass. And we'll see how it is defined in each of the subclasses. And all the transformations are just kind of kept very lightweight, all linear layers. You can make them better, right? Okay.